In this video, we're going to look at a negative externality in the marketplace and calculate consumer surplus, producer surplus, and the deadweight loss. So here's our setup. A competitive market has demand and supply given by the following. So our demand equation, supply equation, and the marginal external cost here. So there's going to be pollution, and the marginal external cost is going to be constant at $2 per unit of output. So the marginal external cost equation, we're going to just set equal to 2. We want to solve for the competitive outcome and then the socially optimal outcome that considers the negative externality. We're going to calculate consumer surplus, producer surplus, and the deadweight loss under both of these scenarios. Sometimes this problem could be presented slightly differently. Instead of giving the demand equations, you might be given the inverse demand. So I just solved this equation for P. That'd be the inverse demand. And instead of given the supply equation, you might be given the marginal cost equation. I derived this marginal cost equation from the supply equation. I set P equal to MC, because in perfect competition, price equals marginal cost. So setting P equal to MC and solving for MC, we get this equation. So depending on the problem that you're presented, you could be given this information in one of two ways. All right, let's move on. So let's talk about the competitive outcome. We're going to set quantity demanded equal to quantity supplied. Solving for the price equals $5, and the quantity, plugging this $5 back into either the demand or supply equation, we get an equilibrium quantity of 10. So this outcome doesn't consider the externality. So now let's consider the socially optimal outcome that does consider the externality. Efficiency requires that price equal marginal social cost, not only the marginal private cost to the producers, but the marginal external cost. So the marginal social cost, MSC, is the marginal cost plus the marginal external cost. Let's get the marginal cost from the supply equation. So as I mentioned earlier, price equals marginal cost in perfect competition. So P, we're going to replace that with MC, and then we're going to divide through by 2. We already seen this equation. Sometimes you might be given this, but we can derive marginal cost from the supply equation by this method. And then we want to get marginal social cost. So we're going to take our marginal cost equation and add to it our marginal external cost. And we said in this problem, marginal external cost is constant at 2. So here is our marginal social cost equation. And efficiency requires price equal marginal social cost. So we can replace MSC with the price and now solve this equation to get us back our supply equation, market supply equation. So moving some things around and multiplying through by 2, we have our market supply equation, which we can now set equal to our market demand equation. So setting, once again, quantity demanded equal to quantity supplied, solving for the price, 24 divided by 4, we get a equilibrium price here of $6, and the quantity, plugging this $6 back into either the demand or supply, we get back a quantity of 8. All right, let's look at this graphically. So our first solution, we found where the demand curve intersected the supply curve, where we didn't take into account the externality, and that was a price of $5 and a quantity of 10. Then we found the efficient outcome, socially optimal outcome, where the demand curve intersected the supply curve that takes into account the marginal external cost. You'll note that the vertical distance between these two supply curves is $2, the marginal external cost. And we found the price was 6 and the quantity 8. So the competitive outcome. Let's now calculate consumer surplus under the competitive outcome. Consumer surplus is going to be the difference between the height of the demand curve and what consumers pay, $5, up to that last unit consumed, the 10th unit. So we got this triangle here, and the area of a triangle is 1/2 base times height. So 10 minus 5 is one dimension of the triangle, and 10 minus 0, or just 10, is the other dimension of the triangle. So we get consumer surplus of $25. In terms of producer surplus, it's going to be another triangle. In this case, it's going to be this $5 all the way to the marginal cost curve up to the last unit sold. So I'm highlighting the producer surplus triangle here. So the difference between the price and the marginal cost curve up to that last unit, the 10th unit, and we have a area of $25. So producer surplus is $25. The last thing we want to get is the cost of the externality. So this market outcome is producing 10 units, but each of those units provides, say, $2 of environmental damage, the $2 of marginal external cost. So 2 times 10, we have $20 of externality being created here, negative externality being created in this problem. So overall, total surplus or economic welfare, economic surplus is going to be given by producer surplus plus producer surplus, 25 plus 25, minus the cost of the externality, so we get $30 here. So that is a total economic surplus under the competitive outcome. Now let's look at the socially optimal outcome and calculate consumer surplus, producer surplus, and the cost of the externality. So in this case, the price is 6 and the quantity is 8. Consumer surplus is going to be the difference between the height of the demand curve and this price of $6 all the way up to the last unit consumed, which this time is 8, not 10. So here is our triangle. We got 10 minus 6 and 8 minus 0 is the dimension, so we get consumer surplus of $16. Producer surplus is going to be the difference between the $6 and the marginal cost curve. And this calculation is a little bit tricky because we're dealing with basically 2 areas, a rectangle and a triangle. So I'm going to break down producer surplus into 2 areas. But again, the big picture here, producer surplus is the difference between the $6 and the marginal cost curve, the private marginal cost curve. So you'll notice here I'm outlining with my mouse here one area of producer surplus. It's a rectangle. And that's what these dimensions are representing. So the width of this rectangle is 6 minus 4, and the length of this rectangle is 8 minus 0, or 8. So that is part of producer surplus, this rectangle. And now you'll notice below that rectangle we have a triangle. So from 4 down to the marginal cost curve, we have a triangle. So the area of that triangle is 1/2 4 minus 0. And it has a base here of 8 minus 0. So adding all that together, producer surplus is $32. And now there is still a cost of the externality. 8 units are being produced, and these 8 units create negative externality here of $2 per unit, or $16 in total. So the total economic surplus, 16 plus 32 minus 16, is $32. You'll notice this is slightly higher than under the competitive outcome. So we can calculate the deadweight loss of the competitive outcome, or the negative externality, as a socially optimal economic surplus minus a competitive economic surplus. So $32 minus the $30 we found on the last slide, the deadweight loss owing to the externality here is $2. So the competitive outcome is inefficient. With the competitive outcome, we get a deadweight loss of $2. Now we could visualize that deadweight loss under the competitive outcome as the area of this blue triangle. So the competitive outcome produces too many units. It's producing units in which the marginal social cost exceeds the marginal benefit, the maximum willingness to pay given by the height of the demand curve. And as I said, it is going to be the height of that it's going to be the area of that triangle. So 1/2 the dimensions of that triangle, 7 minus 5, and 10 minus 8. Deadweight loss is $2. So the competitive outcome is inefficient in that it creates a deadweight loss. It's producing more units than is optimal. All right, I will stop here. Hope you found this video useful.